This is a continuation of practice problems in the analysis of an AC network. Problem 8. Our task will be to calculate the power factor and reactive factor for the circuit shown here. The power factor of an AC circuit is the numerical ratio between the true power, P, magnitude, and the apparent power magnitude, S. It can be seen by referring to the power triangle. This ratio is equal to the cosine of the power factor angle theta. The power factor angle is the same as the phase angle between the voltage across the circuit or load and the current through the circuit or load. Power factor PF is equal to cosine theta, which is also equal to P divided by S. The reactive factor is the numerical ratio between the reactive power and the apparent power of the circuit or load. This ratio is equal to the sine of the power factor angle. RF is equal to sine theta, which is also equal to Q divided by S. In our problem, Z1 is equal to R plus JXL, which is 100 plus J100. That is equal to 141.4 at 45 degree ohms. It may be found using Ohm's law, which is E all over Z1, which works out to 120 at 0 degrees divided by 141.4 at 45 degrees. And finally, that is equal to 0.849 at minus 45 degree amps in polar coordinate format. And it is equal to 0.6 minus J 0.6 amps in rectangular coordinate format. Again, using Ohm's law, I2 is equal to E divided by Z2, but Z2 is just XC. E all over XC is equal to 120 at 0 degrees divided by 60 at minus 90 degrees, which equals 2 at 90 degree amps in polar coordinate format, and 0 plus J2 amps in rectangular coordinate format. IT is equal to I1 plus I2, which is equal to 0.6 plus J 0.6 plus 0 plus J2, which equals 0.6 plus J 1.4 amps in polar coordinate form, and that equals 1.523 at 66.8 degrees amps, and 66.8 degrees is known as the power factor angle. S now is equal to the magnitude E times the magnitude IT, which is 120 times 1.523, which equals 182.8 volt amps. The power factor is equal to cos theta, which is equal to cos 66.8 degrees. That equals 0.394 or 39.4%. The reactive factor is given by the equation RF is equal to sine theta, where theta is the power factor angle, which equals sine 66.8 degrees. And that works out to 0.92 or 92%. Inductive loads have a lagging power factor. Capacitive loads have a leading power factor. The value of the power factor is expressed either as a decimal or as a percentage. This value is always less than 1.0 or less than 100%. The majority of industrial loads, such as motors, and air conditioners are inductive, lagging power factor. Thus, power engineers often refer to capacitors or capacitive loads as sources of reactive power. Before closing off, I wanted to bring you in on a Super Prime Day Encore sale, for which there is only 3 days left. Jackery is offering several of their components for up to 65% off. These are the best essential home backup picks. You can take advantage of this super sale by going to this web address. And even if you miss the deadline, this web address will take you to There are excellent products that you can satisfy your home backup power needs.